I'm not going to do all the parts of the question, I'll just do part A. Other parts are similar. Part A says that we've got a null hypothesis that the population mean is 21 and the alternate hypothesis is that the population mean is not 21. So this is not above or below, it's either above or below, so it's a two-tailed test. So we have X is distributed normally, mean 21, variance 1.5 squared. Our samples also distributed normally, mean 21. This time their variance is 1.5 squared over the sample size, so over 20. We're interested in then is what's the chance of getting a sample mean of 21.2? Is it significant at the 5% level? What does that mean? So sketch yourself out a picture. We're doing a two-tailed test at the 5% level, so that's 2.5% at both ends. Let's go back and work out what's the chance of getting an X bar of greater than 21.2. Well, on our calculator in normal CD mode, we're above the mean, so 21.2 all the way up to all the 9s. Our standard deviation then is the square root of our variance, so it's 1.5 over root 20. And that gives us a value of 0.2754, so 27.54%. Let's put that on our diagram, see what happens. 27.54% of the time we'll get a sample mean of 21.2 or greater. So that's quite often, a lot more often than we need to get it to be significant. That would need a 2.5% of the time. So 27.54% is greater than 2.5%, so insufficient evidence to reject H0, and in context that's insufficient evidence to say then that the mean is not 21. The next part we don't need to do, we've kind of finished here, but it's very interesting to find out what's happening. What would be the critical value? What would the mean of the samples need to be for us to say, oh, we can reject the null hypothesis? Well, we've got to find the probability of a sample mean equaling 2.5% or 0.025. Well, let's do it the other way around. Let's do it less than X bar, so less than 0.975, because we can do that easy on our inverse normal calculation. So area is 0.975, standard deviation as before, mean is 21, and we can see we'd need to get a sample mean of 21.657 or above to reject the sample mean, and drawing that on our diagram, that's the value there, 21.657.